Imagine standing in the middle of the Texas desert, looking at a building so massive it almost disappears into the horizon. From the outside, it doesn't look revolutionary. No towering smokestacks, no dramatic architecture, just a giant rectangle stretching across the landscape. But hidden behind those walls is something that has forced nearly every major automaker in the world to rethink its future. This isn't just Tesla's largest factory. It's a place where manufacturing is being rewritten from the ground up. And the most surprising part isn't how many cars it produces. It's the way it produces them. Because once you see what happens inside, you'll understand why Elon Musk believes this factory isn't building cars at all. It's building the future. Most factories are designed around one simple idea: people build products. Machines help, but humans remain at the center of every decision. Tesla asked a completely different question. What if the factory itself became the product? Instead of improving old manufacturing methods, what if every process was redesigned from scratch? That single idea changed everything. Rather than copying how the auto industry had worked for over a century, Tesla built Gigafactory Texas as if cars had never been manufactured before. Every hallway, every production line, every robot serves one purpose: to remove delays, reduce complexity, and allow the entire system to think more like software than a traditional factory. The first thing that surprises visitors isn't the size of the building. It's the silence. While thousands of machines work continuously, much of the factory feels strangely organized. Instead of crowds of workers moving between stations, robotic arms glide with incredible precision. They don't stop for breaks. They don't slow down during long shifts. Every movement has already been calculated thousands of times before it happens. Parts arrive exactly when they're needed. Sensors monitor every operation in real time. If something begins to drift outside acceptable limits, the system notices long before a human would. And that's where the story starts to get uncomfortable. Because the real goal was never simply to build cars faster. It was to build a factory that could improve itself. For decades, automakers accepted that building a vehicle meant assembling hundreds of individual pieces before finally creating a complete frame. It worked, but it was slow, expensive, and full of opportunities for mistakes. Tesla looked at that process and decided it was solving the wrong problem. Instead of asking how to assemble more parts, it asked how to eliminate parts altogether. That question led to one of the largest manufacturing machines ever placed inside a vehicle factory. A casting system capable of producing enormous structural sections in a single operation. Suddenly, dozens of separate manufacturing steps could disappear. Fewer welds, fewer assembly stations, fewer opportunities for defects. It wasn't simply an upgrade. It was a completely different philosophy. And what happened next would ripple through the entire industry. That single innovation became the beginning of a much larger experiment. Because once Tesla realized it could simplify the structure of the car, it started asking an even bigger question. If machines could build major components with almost no human intervention, how much of the entire factory could eventually run by itself? Walking through Gigafactory Texas feels less like entering an automotive plant and more like stepping inside an enormous computer that happens to manufacture vehicles. Thousands of robotic systems move with perfect timing, lifting body panels, welding frames, applying paint, and transporting heavy components without hesitation. They don't communicate with shouted instructions or paper schedules. Every movement is coordinated through software. Cameras inspect parts in milliseconds. Sensors constantly measure alignment, temperature, pressure, and quality. If something changes, the system reacts almost instantly. In many cases, adjustments happen before workers even realize there was a problem. Humans haven't disappeared, but their role has changed dramatically. Instead of performing the same physical task thousands of times every day, many employees now supervise automation, monitor data, solve unexpected problems, and improve the systems that keep the factory running. It's a shift that says as much about the future of work as it does about the future of manufacturing. Tesla isn't trying to remove people entirely. It's trying to let machines handle repetition while humans focus on decisions that still require judgment and creativity. The factory itself never really sleeps. While most manufacturing plants slow down between shifts or pause for scheduled downtime, Gigafactory Texas was designed with continuous operation in mind. Day or night, weekday or weekend, production keeps moving. Software monitors every production line around the clock. If one machine begins showing signs of failure, maintenance teams often know before the breakdown actually happens. In some situations, backup systems automatically take over while repairs are planned in the background. The goal isn't perfection. It's minimizing interruptions so production rarely loses momentum. But keeping thousands of machines working together isn't simply about hardware. It's about data. Every second, the factory generates enormous amounts of information. Every robotic movement, every battery installed, every inspection result, every completed vehicle becomes another piece of an ever-growing digital record. Tesla studies this information constantly, searching for tiny improvements that might save only a few seconds or eliminate a small manufacturing defect. Individually, those gains seem insignificant. Across millions of vehicles, they become transformational. And this is where the story becomes much bigger than a single factory. Most car companies still depend on long supply chains, with critical components arriving from dozens of outside suppliers scattered across different countries. Tesla has spent years moving in the opposite direction. Instead of outsourcing more production, it has steadily brought key technologies inside its own facilities. Gigafactory Texas reflects that strategy better than anywhere else. It doesn't simply assemble finished parts into completed vehicles. Increasingly, it produces the technologies that define those vehicles in the first place. That includes one of Tesla's most important priorities: batteries. For years, batteries have been the single biggest challenge facing electric vehicles. They're expensive, difficult to manufacture, and responsible for much of a vehicle's cost. Improving the battery doesn't just increase driving range, it changes the economics of the entire business. Tesla understood that long before many of its competitors did. So rather than treating batteries as just another purchased component, the company invested heavily in developing new manufacturing methods that could eventually reduce costs while increasing performance. At Gigafactory Texas, battery production isn't separated from vehicle production. The two processes evolve together. Engineers constantly study how changes in battery design affect assembly speed, structural strength, cooling systems, and overall vehicle efficiency. Every improvement creates opportunities somewhere else in the production process. It's an approach where each innovation supports another, creating momentum that becomes increasingly difficult for competitors to match. But this only matters once you see what happened next. Tesla wasn't satisfied with building one successful electric vehicle. Inside the same factory, entirely different programs began taking shape, vehicles aimed at different customers, different industries, and even different futures. And as those production lines expanded, the rest of the automotive world realized they weren't simply competing against another car company anymore. They were competing against an entirely new manufacturing philosophy. As Gigafactory Texas expanded, one vehicle quietly became the center of Tesla's strategy: the Model Y. At first glance, it's simply an electric SUV. But inside the factory, it represents something much more important. Every Model Y rolling off the production line is the result of thousands of manufacturing improvements working together. Larger castings reduce assembly steps, smarter software coordinates production, better battery integration improves efficiency. Individually, none of these changes seem revolutionary. Combined, they create a vehicle that can be built faster, with fewer parts, and at a lower long-term cost than many people thought possible. Then came the vehicle that captured the world's attention long before it reached customers: the Cybertruck. Its angular, stainless steel body looked unlike anything else on the road. Some people loved it. Others questioned whether it could even be manufactured at scale. Traditional production methods weren't designed for a vehicle like this. The materials behaved differently. The body panels demanded entirely new techniques. Even experienced engineers faced problems that had never existed before. Building the Cybertruck wasn't just another production challenge. It became a test of whether Tesla's manufacturing philosophy could handle something completely unconventional. Inside Gigafactory Texas, specialized production lines were created specifically for this project. New tools, new robotic systems, and new quality control methods had to be developed almost from scratch. Instead of forcing the vehicle to fit existing factories, Tesla reshaped the factory to fit the vehicle. It was an expensive gamble, but if it worked, it would prove that flexible manufacturing could become one of Tesla's greatest competitive advantages. At the same time, another project was quietly developing behind the scenes. Unlike the Cybertruck, it wasn't designed to attract headlines. In fact, it was almost the opposite. Tesla's long-rumored affordable vehicle has become one of the industry's biggest unanswered questions. For years, analysts have argued that electric cars won't truly dominate the global market until prices fall dramatically. Premium vehicles can establish a brand, but affordable vehicles change industries. If Tesla can manufacture a lower-cost model at massive scale while maintaining healthy profits, it could reach millions of customers who have never seriously considered buying an electric vehicle before. And that's exactly why Gigafactory Texas matters so much. The factory wasn't designed only for today's products. It was designed for products that haven't even entered production yet. Every improvement in automation, casting, logistics, and battery manufacturing brings Tesla closer to making lower-cost vehicles economically viable. The building itself is becoming more capable with every software update, every redesigned process, and every lesson learned from previous production cycles. Meanwhile, something else has been happening beyond Tesla's walls. Legacy automakers spent decades perfecting traditional manufacturing. Their factories represent billions of dollars of investment and generations of engineering expertise. But as Tesla's production methods became more efficient, many competitors found themselves facing a difficult reality. Improving old factories wasn't enough anymore. They had to rethink how factories should be built in the first place. Companies that once dismissed Tesla as a niche electric car manufacturer suddenly accelerated their EV programs. Investments in battery plants increased. Manufacturing strategies were rewritten. Partnerships formed. Governments introduced incentives to strengthen domestic production. The conversation had shifted from simply building electric vehicles to mastering the technologies required to manufacture them efficiently. In many ways, Gigafactory Texas became the benchmark everyone else had to measure themselves against. Yet Elon Musk has repeatedly suggested that even this isn't the final objective. The vehicles leaving the factory are important, but they may not be the company's most valuable product. Because every car built, every battery tested, and every robot operating on the production floor contributes something even more valuable than revenue. Data. Every second, Gigafactory Texas learns. Every completed vehicle improves manufacturing models. Every inspection trains quality systems. Every production cycle reveals new opportunities for optimization. Over time, the factory becomes not just faster, but smarter. And if that trend continues, the biggest advantage Tesla gains may have nothing to do with cars at all. It may come from building a manufacturing system that continuously teaches itself how to improve. A system capable of evolving faster than the competition can copy it. But that possibility raises an even bigger question. What happens when the same intelligence that's learning to build cars begins learning to build something entirely different? That something different is already taking shape inside Gigafactory Texas. For years, Tesla has insisted that its mission extends far beyond transportation. At first, many people assumed that meant solar panels, batteries, or energy storage. But over the last few years, another project has quietly moved from concept to reality. A machine that doesn't have four wheels. A machine that doesn't carry passengers. A machine designed to work alongside humans. It's called Optimus. Unlike the industrial robots that have been common in factories for decades, Optimus wasn't designed to perform just one repetitive task behind a safety fence. Tesla's vision is much more ambitious. The company wants to build a humanoid robot capable of learning many different jobs, adapting to changing environments, and eventually assisting wherever repetitive or physically demanding work exists. That sounds like science fiction. But inside Gigafactory Texas, the first pieces of that future are already being tested. The same artificial intelligence that helps Tesla vehicles understand roads and traffic is being adapted to help robots understand the world around them. Cameras replace traditional sensors. Neural networks process visual information. Instead of following rigid instructions programmed months in advance, the goal is for robots to observe, learn, and improve over time. This is a completely different approach from traditional industrial automation. Most factory robots perform one job extremely well. They weld the same point, lift the same object, repeat the same movement thousands of times every day. If the task changes, engineers must reprogram them. Tesla wants something far more flexible. Imagine a robot that can identify a misplaced tool, pick it up, carry it somewhere else, then move on to an entirely different assignment without needing new instructions for every situation. That level of adaptability has remained one of robotics' greatest challenges for decades. And Gigafactory Texas has become the perfect testing ground. Every day, thousands of manufacturing tasks happen inside the facility. Some are repetitive. Others require observation, balance, movement, or decision-making. It provides an environment where new robotic systems can gradually learn from real-world conditions instead of carefully controlled laboratory experiments. That's why many industry experts no longer see Gigafactory Texas as simply a car factory. They see it as one of the world's largest AI laboratories. Every robot, every vehicle, every production line feeds information into systems that continuously learn. Improvements discovered in manufacturing can influence robotics. Advances in artificial intelligence can improve autonomous driving. Better computer vision can benefit both vehicles and humanoid robots simultaneously. Suddenly, all of Tesla's businesses begin connecting together. Cars generate driving data. Factories generate manufacturing data. Robots generate interaction data. Each system strengthens the others. It's a strategy that few companies have attempted on this scale. And that's exactly why competitors aren't only watching Tesla's vehicles anymore. They're watching its software, its AI research, its manufacturing systems. Because the real competition may no longer be about selling more cars. It may be about building better intelligence. If Tesla succeeds, the impact could reach far beyond transportation. Factories could require fewer repetitive jobs while creating entirely new technical roles. Dangerous industrial tasks could become safer. Supply chains could become faster and more efficient. Even industries completely unrelated to automobiles could adopt manufacturing systems inspired by what began in the Texas desert. Of course, none of this is guaranteed. Humanoid robotics remains one of the hardest engineering problems ever attempted. Building a prototype is one thing, producing millions of affordable robots that operate safely in homes, hospitals, warehouses, and businesses is something else entirely. Technical challenges remain enormous. Costs must fall dramatically. Artificial intelligence must become significantly more capable before that vision becomes reality. Tesla knows that. But perhaps that's what makes Gigafactory Texas so fascinating. The factory isn't important because every prediction made about it will come true. It's important because it represents a different way of thinking. Instead of asking how to improve yesterday's factory, Tesla asked what tomorrow's factory should look like. Instead of designing machines that simply follow instructions, it began designing systems that can learn. Instead of separating manufacturing, artificial intelligence, robotics, and energy into different businesses, it started connecting them into one ecosystem. Whether that strategy ultimately succeeds is still an open question. But history often remembers the first place where a major shift begins. Years from now, people may not remember how many vehicles rolled off the production line in a particular month or quarter. They may not remember exactly how many robots worked inside the building or how many batteries were produced each year. They may simply remember that somewhere in the Texas desert, a factory challenged more than a century of manufacturing assumptions and forced the rest of the world to ask a question that still hasn't been fully answered. If factories can eventually learn, adapt, and improve almost like living systems, then perhaps the most important product Gigafactory Texas is creating isn't a car, a battery, or even a robot. Perhaps it's the blueprint for how the next generation of industry will be built. And if that's true, we're not just watching the future of Tesla. We're watching the beginning of the future of manufacturing itself. The next few years will reveal whether that blueprint can truly reshape the global economy. Because building one extraordinary factory is difficult. Repeating that success across continents is an entirely different challenge. Tesla isn't relying on Gigafactory Texas alone. Similar facilities have appeared in Nevada, Shanghai, Berlin, and continue expanding as demand grows. But Texas occupies a unique position within that network. It has become the place where many of Tesla's newest manufacturing ideas are tested before they spread elsewhere. If an innovation succeeds here, it could influence production around the world. That makes every improvement far more significant than it first appears. A robot that saves just 3 seconds during one manufacturing step might seem insignificant. But multiply that by thousands of vehicles every week, then millions over several years, and those few seconds become hundreds of thousands of production hours. The same is true for battery improvements, software updates, logistics, and quality control. Tesla isn't searching for one giant breakthrough every year. It's collecting thousands of tiny improvements that eventually become impossible for competitors to ignore. This philosophy mirrors the way software companies operate. Software isn't released once and forgotten. It evolves continuously through updates. Problems are fixed, features improve, performance increases over time. Tesla has brought that same mindset into manufacturing. Instead of treating factories as finished projects, it treats them as systems that are constantly being upgraded. That may be one of the company's greatest competitive advantages. Traditional factories often require years of planning before major changes can be introduced. Production lines become fixed. Equipment remains in place for decades. Large-scale redesigns are expensive and disruptive. Tesla deliberately avoids that mindset. Its engineers expect the factory to change. Production lines move. Machines are replaced. Software evolves. Manufacturing processes that seemed optimal last year may already be considered outdated today. It's an unusually fast pace for an industry that historically moved much more slowly. Of course, speed alone doesn't guarantee success. Tesla has faced production delays, supply shortages, engineering setbacks, and criticism over quality during different stages of its growth. Some ambitious projects have taken far longer than expected. Others remain works in progress. Even Gigafactory Texas continues evolving, with new production lines, equipment, and technologies being introduced over time. That uncertainty is important to remember. The future described by Elon Musk is ambitious, but ambition isn't the same as certainty. Many goals still depend on technological breakthroughs that haven't fully arrived yet. Fully autonomous driving remains under development. Humanoid robots are still in early testing. Lower-cost electric vehicles continue to face manufacturing and market challenges. Yet despite those uncertainties, one fact is difficult to dispute. Very few companies have invested so heavily in redefining how products are made rather than simply improving the products themselves. And perhaps that's why Gigafactory Texas attracts so much attention. It's not because every prediction surrounding it will come true. It's because it represents an experiment unfolding in real time. An experiment asking whether artificial intelligence can optimize manufacturing, whether software can become as important as machinery, whether factories can eventually operate with levels of efficiency that previous generations considered impossible. No one knows exactly where that experiment will lead. Maybe decades from now, Gigafactory Texas will be remembered as the birthplace of a new industrial era. Or perhaps historians will point to it as one important step among many that gradually transformed manufacturing around the world. Either way, its influence is already being felt. Every major automaker now invests more aggressively in electric vehicles. Battery technology has become one of the world's fastest-growing industries. Automation and AI are moving from optional tools to essential competitive advantages. The conversation has changed, and sometimes changing the conversation is the first sign that the future has already begun. So the next time you see a Tesla driving quietly down the road, it may be worth thinking beyond the car itself. Behind that vehicle stands an enormous network of engineers, software developers, robots, battery scientists, and manufacturing systems working together inside one of the most advanced factories ever built. A place where every second is measured, every movement is analyzed. Every improvement becomes the foundation for the next. Because in the end, Gigafactory Texas isn't really a story about a building in the desert. It's a story about how one company challenged assumptions that had shaped manufacturing for more than 100 years. Whether Tesla ultimately dominates the future or not, that challenge has already forced an entire industry to evolve. And perhaps that's the most remarkable part of all. The biggest revolution wasn't the electric car. It wasn't the giant casting machines. It wasn't even the robots learning to work alongside humans. The biggest revolution was the realization that factories themselves can become intelligent systems, constantly learning, constantly adapting, and constantly improving. If that idea continues to spread beyond the automotive industry, then the real legacy of Gigafactory Texas won't be measured by how many vehicles left its assembly lines. It will be measured by how many industries decided to build their future differently because of what started there. And maybe, years from now, when people look back at the early days of intelligent manufacturing, they won't ask when the future arrived. They'll ask when we first realized it had already begun.